right, we should be live. Maybe.
Good morning, Olivia.
Good evening, I guess.
Yeah.
I always have to check because I now put it as a watch thing, so it's 8. It's 8 there.
Yes. It's 8 p.m. in the evening. Well, 2 p.m. is always in the evening.
And we are waiting for people to come on and join our EV conversation because that'd be a lot of fun.
Yeah.
Oh, wait. Let's not do that. Let's see. I know everybody's seeing a desktop right now, but that's okay.
I'm going to try to connect to our stream.
Let's see our stream and see if people are on, so we can talk about EV routing because we both love EV routing.
I just like
routing.
So
a few people coming on.
All guys. Yeah, actually we are looking fine. I can see the stream going. Yeah.
Okay, good. Good. So let's see. There's some people coming on the stream. And we do have the QR code below still because we changed that so we don't have a weird bit.ly in the ticker because I feel like that was hard as it flies by. So we have a QR code now for the API credits.
Remind us again, what is the how many credits do we have?
Yeah, you get 10,000 API credits. So basically API calls for people aren't sure what the credits mean with the dev POI promo code, which is what's basically down below.
Yeah.
So, and I know I put out on Twitter that we're basically, Jose and I both have I think we're both into cars. I feel like, Jose's into also electric scooters, which is very cool. But we want to see what electric cars we can actually do reachable range with because it's pretty customizable. So we want to take some really fun cars and see if we can see that we can route them, which I'm excited about because I'm a car nerd. Maybe there are other car nerds around. I'd hope so.
I'm still taking an eye on that list that we found. I think I'm going to select my next electric car from there.
I think my first electric car would be there. Have you had an electric car before?
No, just the motor, the scooter, and I build my bicycle. That's it.
That's probably the project after I retrofit my car to be self-driving with the kit.
Have you heard of these motors that you can replace your wheels with already controller, and you can make any car like electric already?
Oh, so I was wondering about that. I wonder if I could do mine. If I could like retrofit it to be electric.
Yeah, it seems to be like very easy to do. Not much effects of the functionality because it's just switching a wheel, right? Switching wheels.
That's interesting.
And then your car automatically will be a hybrid.
That's actually super useful. I wonder if it will work. I wonder what model year it starts and stops working. But
someone sent me a link the other day. If I can find it, I will find it for you. But I was very interested. You cannot get that. I haven't seen it here in Europe. So
maybe I can live stream me retrofitting my car and then try to route my car. The ultimate experiment in reachable range. See if a altered 2012 Volvo can.
Oh, is your Volvo an automatic car?
Yeah,
it's automatic. Because it has to be automatic. Of course, makes sense. It has to be automatic.
So that's the fun part. But now we're probably on to the Devisode in terms of more EV routing because we can talk about cars and things like that all the time if left unattended.
Yes, we don't want to go over their allotted time.
We always seem to do that anyway, so I feel like we shouldn't try to this time.
Yeah, it's okay.
But
it's okay.
Without further, basically routing, but electric. We've done a routing episode before where we just sort of did the basics of routing. I think when we first started streaming, because we've done a lot of, I think, initial episodes where we did some setup on, how to first make the map, how to add in routing, which I think is sort of one of the next simplest things to do. And we've,
Yep.
I feel
Yep.
like, done a little bit of the like EV routing. I think because we did with trucks, the consumption models are different with trucks, right, Jose? Like, they burn
Yeah.
obviously a lot more fuel. It's different, the range of a combustion engine truck is also different than an electric truck. Obviously, it's a whole thing.
Not only the routing API have to adapt for trucks, of course, because of the restrictions on the street, but also for the capacity, the consumption, in gasoline or diesel is different. You have to have different measurements. So the routing API, good that it depends on what kind of routing you want to do. That's what we did last time, and today it's going to be electric. So it changes a bit.
Yeah, it does change a bit, and I know we did quite a few, I think, episodes with the truck routing specifically in terms of the routing for for stops and waypoints, and not all. The big thing that we talk about is that trucks are not allowed on all of the routes, which is why you see the routing change, right, with the weight limits and things like that. And we did a lot on that, but I realized that we never really, we realized that we didn't have a dedicated episode specifically for EV routing, and it's one of our favorite things to talk about. I remember when in-person meetups used to be a thing. I did a meetup on working with EVs and very similar to this. And Jose likes to talk about you like to talk about it as well because Jose has that scooter, the electric scooter that you work on. And it's a very fun subject for us.
Mm.
And so today we're going to mostly hit on the points of reachable range, battery consumption differences, and then we might do charger finding. Finding chargers along the route is, I think, probably one of the top ends of the topic list in terms of finding chargers along the way and things like that. Is pulls in a little bit more information, right? And route planning, you can plan a short distance route a lot more easily than you can plan a long distance route with chargers.
Yes. Not only you can get the charging stations using the extended search API, you can also get the availability, so when or which one are free to go on charge or which one are already taken. Yeah, it's very useful. Yeah.
No, and that's part of the API, which I found was really interesting. But putting it today on the agenda, I think, is harder. So we're mostly going to be talking about reachable range and the battery consumption. Even though we'll talk about charger finding and things like that, but our example probably won't have charger finding. We'll probably do a part 2 for electric vehicles if we want to do more charger finding and people want to know more about it.
Yeah.
But
yeah. Yes, it's quite a long topic to do all the way up to long distance routing. So
yeah,
let's take a look. What do we have today?
Look. Let's see. And the next
Reachable
one is
range.
we'll do we'll talk about mostly reachable range, so sort of short distance trips. But before we go into picking the car that we want to route, because we're all going to have biases, and if there are people in the chat, if you want to suggest your favorite fancy electric car that you want us to route, we'll we're taking suggestions. And what I wanted to
No, did you have already the are you sharing the website already? Yeah.
No, I'm gonna talk about the battery metrics because I know that most of the people watching are in the US, so I figured I'd go through how to convert it over, because this is something that I had to figure out kind of manually how to do when I first started working with the API. Was to realize that EV consumption, I think generally speaking, I think within the industry is measured in kilowatt hours, or kWh. And if you don't know that acronym, and you have to look everything up like I did, I sort of did a cheat sheet here real quick. But other measurements, in the US, I think we still use MPG or EMPG sometimes. Like you see it in advertisements, is still used even for electric cars because that's just the metric that we're most familiar with. And so how to sort of equate it over is that 33.7 kilowatt hours equals 1 gallon of gas. But the distance, the value, is about, right? I think it's about a gallon of gas in terms of like how far it gets you, because it's this whole exercise in how far a certain battery charge, gets you. And then the value is measured in, kilowatt hours per 100 miles, which is basically, the rating of the, how far the car can travel on its battery charge, which means that a car that uses 20 kilowatt hours per 100 miles has an MPG of about 168.5 miles per gallon. So that would be,
It just I have to say wait, it's a kilowatts per hours per 100 kilometers, not per 100 miles. Careful.
Is it per 100 kilometers? Oh, it's per 100 kilometers. Oh god.
Kilometers,
okay.
Yeah. All the APIs are in metric in total.
Yeah, they're all in metrics. So that's the one edit. I can always go back and edit in the description. But that's the one edit for the 100 kilometers. So
yeah, but your calculation is correct. What is in the slide
calculation
is
is still correct.
Yeah. Yeah.
So calculation is still correct in terms of 20 kilowatt hours to drive 100 kilometers has an MPG of 168.5 miles per gallon. So that's a my bad. But I'll also shift over to, we also have an article that actually shows this pretty well. Let's see, this one shows planning the route with electric charging, which actually does the calculation out. So you actually see that we have a blog post where you can actually go and see the conversion worked out in terms of, that also quotes the 33.7 kilowatt hours to travel 1 mile, and the whole 100 per 100 kilowatt per 100 kilometers conversion. But now we'll go over to the famous website where we found, Jose actually found this, the website on.
Can you put this URL in the chat?
I'll put the URL in the chat. Yeah, let's do it. Of the
also,
sort of EV database. Here, tell me how you found this. Oh, go ahead. Yeah.
Wait, I heard that we have already more than 200 followers.
We actually do. So
I was so surprised. Very
shout
nice.
out, and I think we'll see. Let's see. Do we have people? We have people on. So we hit 200 followers, which is actually very cool because we.
Very nice.
Yeah, this basically started as a big experiment for us. Yeah, no, thank you. Because obviously with the world being the way it is, we had to really do a shift over from in-person meetups, which is what Jose and I normally do. And so we're really happy to have 200 people in the TomTom Devs Twitch community. It's a lot of fun. We've had fun streaming.
Yes.
So big thanks.
Thanks.
For I think 200 or 201 followers.
Yeah.
Let's see.
Okay, let me see. Do you have? Okay, I have the link. I found the link of evdatabase.org.
Yeah, so I have it on here.
Yeah, that one. Yes, exactly that one.
Yeah, you can see it.
Zoom in. Can you zoom in a little bit?
Yeah, I know. It reads really small here. Okay. All right, so we can see we have Tesla. We have, I think, even the Polestar's on here, which is the Volvo made electric car. Question mark? Yes, I think so. So we get to pick a car now.
Which one would you like? Ooh. Or maybe someone in the chat have an idea. Or
anybody in the chat want to suggest a car?
Choose any car.
Any car. I'll even do a little bit of scrolling here.
Range of any car you select.
Yeah, because all the info's on here. Now, how did you come across this website? Did you just found it?
Online search, yeah.
Yeah.
Online search. Most of the information is freely available from your dealership when you buy the car. Also, there are many industry related blogs, articles, when they analyze and they review different electric vehicles, of course. And this one was very interesting because it's called itself database. So, okay, let's take a look at this database, and very well organized. I like it. So I can send you also. I can also put the link on the chat if you want, so people can find it interesting.
Yeah, no. Let me. I can throw the link in the chat. I definitely got distracted because of our 200 followers celebration, but let me paste it in the chat and say, here's the website we used, everybody. So if you're watching, or if you have us, on your third or fourth monitor too, definitely go check out the site when picking your new electric car.
I have to see you're streaming here and.
All right, so I'm biased, and I always want to pick Audi.
Which one?
The S55 Quattro is a favorite.
Which one?
The S55 Quattro.
Okay, S50. This is Sportback.
Yeah.
Quattro.
So I have it up
Okay.
here, and you can scroll down. It actually has quite a good info. Obviously, it has info on the price, which is that's far away on the list, I think, for now. And we
e-tron, I cannot find e-tron Quattro. No, it's
it's the
55 Quattro.
S55. Yeah, S55
Quattro.
Quattro.
Okay.
I decided to pick a really
Okay.
complicated. Let's
Okay.
see. We go down. Oh no, we go down to the real energy consumption.
Yeah, you don't have to go that far. Energy consumption. There's a what we really want to see is the real consumption that they have to. But yeah, real consumption or real energy consumption estimation, which is okay.
Yeah,
Estimation.
so that's what we have in the
are
different weather, right? Because weather does affect some of the energy consumption of the car, and so you see it. It says cold weather, and even specifies that cold weather is -10 degrees Celsius, which is cold. And then we
cold.
have mild weather.
We can use a calculation for mild weather today, for
Yeah,
example.
so the city mild weather is basically 190, and it's WH,
Watts.
so that's just
It's
watts
watts.
per kilometer, right, Jose?
Correct.
Yeah, and so we
And
do a little bit of
the
math.
API, yeah, the API is asking for per 100, right? So
Hmm.
that means we have to multiply this. So it will be, the first one will be 19,000. That's 19 kilowatts per hour, per 100 kilometers.
Oh, okay, so 19 kilowatts per hour per 100 kilometers, and then
And
the
the other one will
highway
be
29 or
should
the 30.
29.8 kilowatts
Yeah.
hour per 100 kilometers. Now,
Okay.
we have to select also, or to select what is a speed, what will be our speed in normal city riding and normal highway riding. I
Hmm.
understand in the US will be miles per hour. That means a city will be around 35 miles per hour or something, like 50 or 45 kilometers per
Yeah,
hour.
it's something in that range, right? Depending on the city.
Okay. How about highways? I know that you have highways called
So highways are
I
usually
something.
65 miles per hour, which I think, what does that work out to? So 62 is 100 kilometers per hour, right?
Correct. Yes. So we can average 100 kilometers per hour if you want.
Yeah.
Just
Yeah.
to make it a little easier. So we have the around, when you're driving in city, around 45 average kilometers per hour. Then you will consume 19, 19 kilowatts per hour every 100 kilometers.
Yeah.
And if you're on the highway, you will consume around that speed average of 100 kilometers per hour, you will consume 29, almost 30 kilowatts per hour every 100 kilometers. And those two values we're going to need it because that gives us an idea of the consumption, right?
Yeah, that basically gives us like a compact version of the consumption model for at different speeds. But we'll obviously lay it out a little bit because we also have examples on the dev portal which actually show this pretty easily.
Yeah, correct.
And that's and we so like averaging the 100 kilometers per hour speed, we can go ahead and see what falls in the range, right? Going based on the consumption model for the specific model, of course. So here the Audi e-tron, the S55 Quattro, the very long complicated Audi that we picked. We can go ahead and see what's
Good.
where you can go in a single trip, and then we'll go ahead and even create a route for it, like a short distance route, not one where you have to stop and charge necessarily.
Yeah, I also need to know how much is the car, what is the weight of the car?
What is the weight? We can see. I can actually
Because
tell you, I think.
it's heel loaded. It's
Dimensions and weight.
2695. Yes.
It is
Weight is also
3245, yeah.
useful. Yeah. To
Yeah.
calculate also for inertia on when you go into the riding, and also for restrictions if necessary. But okay, we can use that if we need, just to get the value in here. So it says here gross vehicle weight is 3,245, almost three tons, 3.2 ton. Okay, got it. All right. So what do you want to do? Let's go to see one of the samples.
Yeah, let's go here. I'll shift it over to you, and we can see one of the
Right.
yeah, we can see the example just for reachable range. So this will give a really good visual idea of just how far a car, not necessarily this example car, but how far an example car with a customizable consumption rate can actually drive within a given city. Like, can you actually cross your city? Do you have to sort of stay within a certain mile or kilometer bounds, or what's going on, right? So
Yeah.
there you go. So your screen should be on screen. So I see it's the same. Oh wait, never mind.
No, didn't cut.
All
Didn't
right, here
change.
we go.
Technicals.
We had the
Technicals.
spinning TomTom logo twice, but that's okay.
So right now I am at the developer portal in the example section. And as you can see, I am checking the new Map SDK for web version 6. And we have a couple of samples here. And today we are going first. We're going to start with the reachable range. And want to see in this example, you can try combustion and electric. Let's go for electric. We can also check if a car or truck. I'm going to select car. And let's see. And a car. So what values did we decide? We select before it was
100 kilometers
it's
per hour, right? Because that's sort of the average highway
correct.
speed. Yeah.
Well, we selected 45 kilometers per hour on the city at this consumption. So let's take a look. So the first one is not 50, but 45 kilometers per hour, and the consumption was 19 kilowatts per hour every 100 kilometers. And we're going to add another row, and we'll say 100 kilometers per hour. We are consuming almost 30, that's 29.8. Let's put 29.8. Okay, and in this sample, we have an energy budget. That means how much battery do you have, actually. And we can budget, in the API, we can budget for, in this case, energy, how much battery you have, or how much time you can reach out. Let's take a look. So this is a pull down menu. Oh, well, it's allowed me to select 10, 15, and 20. Let me double check here in the Audi e-tron. What's the max? The battery charge, the battery on this. Battery capacity.
The battery capacity, I think, is
95.
Yeah,
95 kilowatts per hour. That's a big battery. But the one that we really care is about this one. Is this one?
Yeah, because
the 86.5.
That's the usable battery basically after all of the sort of non-driving capacities used up for the car, right?
Correct. This is the real energy that it can be used for actually power the car.
Yeah, for the driving, so not other things. Like, what are other things, I suppose, that could be using the battery from the car, like things like
navigation
radio,
system,
lights,
radio, lights, electric lights, heaters, I don't know.
Yeah, other things that you need.
Correct. Also in your car. So obviously in these samples, I cannot go out to the maximum to see if I am charged, but I'm going to select 20, and we're going to write our own code to do this what I'm doing right now, just to get a little more realistic. Let's see. I'm going to submit. And what it does is, okay, I see several things here. First, there is an area, and this area represents the distance that you maximum can go with this amount of energy.
So the perimeter is basically the farthest extent. Yeah.
Correct, according to these parameters here. And this example also is very nice to actually perform I'm pretty sure it's a fuzzy search of all the charging stations inside that polygon, that reachable range area, which is
possible. Oh, sorry, go ahead.
I was going to say using the search API, you can search around a polygon, and since we already got the polygon of the reachable range, it's quite easy just to perform the search. Now, I'm zooming here. I can see this is only Amsterdam. What happens if I click here? Nothing happens. Okay, so it's just a representation since this sample has to do only with reachable range. Quite interesting.
But I think also something interesting is that it looks like the perimeter does only fall on roads, basically. It's a polygon, but it's also mapped between different areas where you would actually hit your reachable range, but on a mapped road. Because, for example, some of them, you see that you can't just sort of laterally drive through the open space that's there because there's not a road there. So it draws the polygon along that road where it's like, oh no, this is the road. Based on the distance of the road, because roads aren't in straight lines. If they were, it'd be different. But the distance on a road that you'll travel Yeah.
as a guideline. Yeah, I understand your point. For example, yes, I can see, for example, that the maximum, if you go on a highway, this would be the maximum distance in theory you can reach. Yeah, but obviously you cannot get here or here. There is no road. Yeah, it's just an area.
Right.
Yeah. Interesting. So let's take a look
Interesting stuff.
our code. So for today, I have prepared. Let me see if you can see my code. Oh, we have a very standard initial file, which I don't want to start adding the maps again. We already have the map. We already have the API key, and I added I was trying to do the same thing with this auto, which is the one that I selected at the beginning, is the Ionic. The Ionic car, but no, we're not going to do the Ionic. We're going to create, let me see, let's create another one. This is the Audi.
So basically we're creating a variable
An
here
object
that has all of the,
correct.
yeah, it has all of the attributes for, that describe the type of vehicle and all the other points that we need to talk about the consumption model and create the route, right? So we have the speed consumption in kilowatts in kilowatt hours per 100 kilometers, which is very long. The engine type, we have, what else do we have? We have the weight, which also affects the wear on the battery. The charge that we want to start with, so same that you're not always starting with a fully charged battery. And then what else do we have? The maximum charge, which is the maximum the battery can hold.
29.8. Now, yes. Now we have the vehicle weight, and I say it was almost 3 tons, right?
Yeah, and what's in the array that Jose's adding is those are the consumption models. They're based on the two, we're doing basically city in mild weather and highway in mild weather, I think, right? Mild weather.
Correct.
Okay.
Mild
weather. It's a tongue twister kind of day.
345. And okay, and what's the maximum charge of this battery? Is 86.5. We're gonna take this one.
90. Yeah, 86.5. Right. That's the usable.
86.5. Oh, so we're gonna calculate always being full. Like, yeah, let's say we are always calculating the maximum range. Just an example. We can also select the half of the battery will be 43. So for half of the battery, how long can you get also?
Yeah, so on a halfway charge.
Yeah, that's 0.25. Okay, we have our API key, and I think we are, I saved this as Vancouver, if I'm not correct. We're going to Vancouver today. Let's see how it looks like.
Is that the starting point for us? Is that we're doing the save location as our start point?
Yeah, Vancouver. Let's see, reload here. Yeah, it's loading Vancouver, British Columbia in Canada.
Yeah, so what's going on here is there's an example that we created already that has the code that you see us editing to create the parameters for the Audi, and we have the starting point already, so you can actually see the example without us doing the same legwork that we've done a few times before with the routing, because we've gone through routing before. So if you want to learn how to actually build sort of the base code for routing, that's in the previous Devisodes, and we can always link them to, or we can always link them at the top, so that if you come back to this one, you can piece it together. But we've done that routing already, so here we're just focusing on the sort of EV aspect and the waypoints to get our reachable range.
And in this in code right now, I have added the minimum fuzzy search to searching a location and to add a marker on the map, which we have done already before. So what I do, I use the fuzzy search, and I am taking the value that is in the ID source element in the HTML, which is this element that is here. I'm filling right here. Let me see if I can zoom in so much better. This element here, and then when I click add waypoint, we're gonna add a marker and save it for now. So let's see. Let me see if we.
Where should we add a marker? Another marker.
It should work. Let's go from Seattle.
Oh, to Seattle. Let's do it.
There's only one. Yeah, it is Seattle here.
Ah, we see Seattle.
Seattle. Yeah.
Right in downtown. And then,
yeah, it sets downtown. Let's see another one. Let's just.
We don't have to British use Columbia. It, we could do British Columbia. I was going to say you could do Portland, but that'd be a long distance trip.
Well, sorry, it's farther away. It's in Canada, so I prefer Portland.
Let's see if we do Portland.
Portland is in Oregon?
Yeah. So just another state down. Let's see.
Where is it? Oh, it's
there
quite
you go.
south.
So we have our Pacific Northwest road trip in the Audi, which actually very fun, very fancy, very fresh.
I wanted to go. Okay, cool. So okay, placing the markers works, and well, okay, let's create a way to store them. So I have a variable with an array of waypoints. They keep the markers and locations. So every time we create a marker, we're gonna add what's here. Here's the marker. So we have a marker. We have done this before. We got the little graphics. The dot begin is here. Yeah, this is the dot, and we create the marker with that element. We usually create the same results. The first result. Let me get the first result.
Yeah, I think we did also markers and customizing markers. I think we even maybe did a little. I don't know if we did markers last time with or if we did with POIs, but we've definitely done episodes where you can also customize the markers, and we have tutorials on how to place the marker as well. Since that's another thing that we covered early on is placing the marker and placing them on click as well, as opposed to from the fuzzy search, which is sort of that's probably one of the favorite basic topics is adding the marker on click. That's a nice way to just sort of have a usable map at the base level. But this is obviously, we're having a search and then the search results is automatically placing the marker instead.
Yeah. Well, okay, we have the waypoint. Waypoints. Let's add an element, which is information about the object that we just added. The first one is going to add the marker, which is we just created, which is this one. Marker is marker. Then the position, the location, should be from this element position, which we already have the set lat and long here. And let's store the address, physical address.
And that will help us with routing as well. And what's going on is that we're adding each waypoint that comes out of that we place coming out of the fuzzy search in the example that you see to an array, and that way we can use it for the routing later on.
I don't remember exactly what is the name of the inside address. I think it's called freeform something. Let me just double check.
Freeform.
Here. Well, let's paint it in the console and see what I got. Let's see, Seattle. Okay, I have in the console here. I have the result. The first element usually is that one, and we have a address.
Yay.
And the address is freeform address.
Freeform address.
Freeform address. That's what I want. Correct.
So we can take freeform address and help it use it to add
our
address. Or we can use all of the console log.
Form address. Yeah, freeform address. Okay, now we are saving them. And once we got all the waypoints saved, we can create a route, which we're going to do soon. But first, okay, let me see. What do we have already created? I have the Audi, I have location,
I have the variables with everything from the Audi,
Yeah, how about every time we click, we calculate the reachable range from the moment we click, from the location
that would help.
we click?
So we can click anywhere on the map and we can see sort of the max driving distance on the current battery charge, right? Because we have the battery charge stored in the variable for, say, the Audi, right? So we could get it for either the Audi or the Ioniq.
Yeah, so right now, every time we click, it moves the map.
Right.
We move them up every time we
Which
click.
is actually really
right here. Okay, just move them up. But I don't want to move them up. Well, we can move them up. But also, we want, from this location, we want to calculate the reachable range of the Audi information that we have here.
Yeah.
So let's take a look. So the first thing is, in doubt, we always have the developer portal. So I have to check here that we have in the SDK for web, reachable range. Do you see it? Calculate calculate
Reachable range up there, yeah.
Reachable range. It's just receive the API, the location, and then the consumption, which we already have, and we have the type and everything. So we can do that. We say very easy. Let me see. Let me read key origin. Got it. So let's call TT services, and let's calculate, not root, is reachable. Reachable range.
I actually found, like, even just reading the documentation, reachable range is really helpful in terms of just explaining what all the keywords are. Because, for example, when I think started looking at EV-based development with the APIs, I had no idea what the sort of constant speed in kilowatt hours per 100 kilometer meant. But you can actually see where it's used, which is nice if you want to look before you actually start writing things out. It helps sort of place all the keywords in a sensible, sensible order.
Electric, this is called engine type electric. Now we have to pass, what's the parameter for the, it's a mouthful. Constant, speed consumptions in liters per 100 kilometers. Oh, this is not liters, has to be in kilowatts.
In kilowatts, and that's the difference, because it would be the same thing for the combustion engine. But you change it for electric.
Speed consumption in kilowatts per 100 kilometers. It's a mouthful, and it's very mouthful because we already know that information. We already got it, right? That's the easiest part.
I feel like there's not a way to shorten it down anymore, because you wouldn't know what it's saying if you made the name shorter. I feel like it would be worse.
So it's from the, actually I call it the same here in the object, OD. So let me study the Audi.
Let's see.
Yeah, constant speed consumption per 100 kilometers. Correct.
So it's a very long line. Just one very long line.
All right. What else do we need? Okay, we already know how much can the consumption it is, how much it is. We already know the location.
The variable. Yeah.
We're missing something. We're missing how much do we have right now? We're missing their budget.
The current.
How much do we have?
Energy budget.
How much battery do we have in the moment? So let's take a look.
But that's also in the variable, right? So we just fetch it from there.
I think it's called energy something.
Like energy budget in time. Oh, energy budget in kilowatt hours.
In kilowatts per hour.
Yeah.
Okay. So energy budget in kilowatts per hour. I wouldn't want to make a mistake on upper and lower case, so I'm going to copy it better.
It's always the bane.
Yeah, the correct one. So how much we're going to, we don't have to guess. I'm going to add the current charge.
Yeah. I think we did a half charge.
Yeah, we do. We did. We have 43.5. It's half the maximum charge for now. No. And I think that was it.
Yeah, that's so all we'll be able to find the reachable range for our
reachable range. So so this thing is of course return a promise, which of course result a function with the result here, and let me see results here. And the result we can, I know that in the result we usually receive a GeoJSON that we can add into a layer, which is very easy. We just did it the same way we create a route, for example. But for now, let me take a look. What exactly are we getting? How about that?
Yeah, then we can see what the return is.
Yeah. Let's see. Let's go back to our code, reload. All right. So if I click here, I got something.
Getting something back. We're just not painting the reachable range as the polygon, I don't think yet, right?
Yeah, it's a reachable range, and there is a boundary, there is a center, and there is a function called GeoJSON, and that's what we need. We need to create a map layer and to GeoJSON and see how it looks like. So I have quickly, let me see. We did this for creating a route last time. Let me see.
Yeah.
Let's go back to
And let me see. So boundary reminds me of the geofencing because I imagine that if I were to take, so boundary, I'm assuming is returning an array of points, and if say I were to manually plot those points, I would manually be creating the reachable range polygon.
Correct.
Yeah.
So let me see. I'm gonna copy the code that we did for the other one time, or the reachable for we did that for the previous, I think, well, long time ago, other episode. We call it reach. It's a field, it's a GeoJSON, and we have the color. It was orange with a 66% opacity and an outline.
It reminds
Now
me
we're
of the
gonna add that
geofencing.
layer. Yeah, I think
Yeah.
it was called like that.
The aliens.
So the result
when we map
has
Roswell.
to GeoJSON, and let's call it GeoJSON. And the result to GeoJSON, and put the layer and see how it looks like. Okay.
So we should have
let's
an
take a
orange
look.
reachable range polygon.
Yes. Let's see how it looks like.
Let's see if it.
Okay. From here, click. Voila.
Ah,
Was
cool.
quite long.
So the e-tron can actually go pretty far on half its charge, which I'm
On
impressed
half
with.
its
Makes me
charge.
want to buy
Very
it even
impressive.
more.
Yes. Now if I click someplace else. Oh, okay, got it.
Ah,
We
so
didn't
it works the
remove.
one time.
We did not remove the layer.
Oh, we didn't
because
remove
it
the
has,
layer, so we can't have another layer.
Yeah, I mean, it's called reach. You can see it there, obviously. So, okay, let me see. If map get layer, oh, I remember. Map get layer is called reach. So this will return. This will return the layer called reach, and if it exists, you just have to remove it.
Yeah, remove it before creating the new one.
The new one, yeah. Yes. Okay. And wait, when you remove the layer, you also have to remove the source. I have learned my lesson. Many
Did that
times.
happen on the Roswell episode, or am I remembering wrong?
Yes. Also,
That's what happened?
it happens on the Roswell episode. It happened when in the truck routing episode as well. You remember?
This
every
is your
time.
fate, Jose, is to remove the source.
Every time I forgot to remove the layer. Okay, so let's take a look.
Extra point, I feel like the not removing the source is our own version of the Roswell incident at this point. The Roswell incident.
Okay, that's the range if you are in Vancouver, but if you are in Portland, voila. This is your range.
So you can still drive to the beach. That's important.
Oh, wait, what? Oh, yeah. With half.
I mean, it's only about 2 hours.
Oh, I didn't know that. Eugene.
Fun facts.
Fun facts.
Oh, wow.
Yeah.
Interesting.
Yeah, you can reach that. Where is Seattle? Here. Boom. How about that?
As I was saying before, which I feel like I'll say again since we have more people on the stream, is that the polygon is also shaped so specifically because it's designed to make sure you are actually on real roads. It's not just a random it's not a random perimeter. It's actually on real highways and other streets, so that it's you actually have an end point of wherever you're driving, as opposed to just you obviously wouldn't just be driving in a field unless you just turned off the freeway like a
yeah.
I don't know what would be happening then, but it's actually on real roads is the point of the polygon.
So let's create a route and for this car to go from one place to another. Let's say
with
Vancouver.
the waypoints.
Yes. What waypoint? This is Vancouver in BC, and then let's see another one, Seattle. Just for saying because close by. I don't know.
Yeah, and we were not doing long distance, so we're not doing with charging stations.
All right, so you have 2 points, and now we're going to, I added this button before, that it does absolutely, it does create the route. Yes, I copied the same code for the other one. And let me tell you what happened here. We did create this route before. I'll show you what happened. When create the route, what we take is, remember the waypoints that we created before? Mm-hmm. So from each waypoint, we get the location and we create an array. That's what we use the map function.
Waypoints. Yeah.
Yeah, and they get the locations, and then with the parameters. Oh wait, this is wrong. It's an error here. We are using. I am joining 2 JSON objects together. The first one is because when you create the route, it needs parameters, and the parameters is the API key, the waypoints, and more information. So I'm adding all the information that belongs to your Ionic, which is wrong. We have the information belongs to Audi.
Audi, yeah.
For the Audi, so correct. And that creates could be a different route, could be the same. Yeah, we don't know. And then we could just create the route and we just draw the route, which we did already with the same code that we did before, which is exactly this. When the route exists, we remove it and add the layer with a simple route. We've done that like several times, so that's why I added there. Now,
yeah, so a lot of the routing code specifically, obviously we didn't want to rewrite it live because we've done routing several times. It's kind of a really inherent part of the library. So for example, whenever we did the car carrier, like the matrix routing, that was already based on the basic routing episode even then. So routing is definitely sort of a little bit, way back there, but if you still want to go look at it, that's still a fine place to start. But that's why it's sort of done for us here, is because we're just showing how far you can drive and that you can drive on still half a battery on this trip, as opposed to showing things like distance and the charging point, as we're just doing the routing with the EV on the single charge.
I want to show you what is the GeoJSON value, because once we create the route that is only for electric vehicles, we have different elements in it. I'm going to remove the console print here, and I want to see how it looks like. I'll show you. Like if you select, so again, Vancouver, easy. And the next one is Seattle. Waypoint. Let me see if there. I'm going to
2 waypoints again.
Yeah, I'm going to go with the console, and then we're going to create the route. And okay, that's another thing, but we have to.
That's because we don't have charging stations. Yeah.
We don't have it yet. Yeah. So when we create the route, you can see in the features, this is the GeoJSON that we just draw. There is a section called the properties, and in the summary, there is a section.
Oh, we see the information. And we even have more information like arrival time as well, which I think is interesting. So we set our departure time, and then it's going ahead and estimating when we would arrive in Seattle? Is it a real arrival time?
That is a real arrival if you click now and we with this auto. But I wanted to let you know that how it tells you, because we already know how much this auto actually consumes and for how long it will be driving and for what is the distance. But all this is normal information coming from the routing API, even including the arrival time, for example. You can get all the time. But because this call was for an electric vehicle, we get a little bit more information. And it tells me that I am consuming for this route 67 kilowatts.
So 67, yeah.
Do you remember what was the charge?
I think we did half of 86, because 86 was the total sort of usable battery capacity.
Correct.
So that we would have done 40 something.
86. So 86 is the maximum usable battery
so we would
charge.
still run out of charge on that route.
Wait, no, 86, no, 67. We actually can make it.
But which budget did we? Well, in one full charge. But if we started out not fully charged, we would have to stop.
If I click here, we only can reach half of the distance because we are estimating with the
so then you see the comparison.
reachable range only half. Yeah, if I start from here, we only can reach it up to here, probably until almost half the distance.
Which makes sense. But it's interesting that this is showing and you see all the information in the console log, because if you wanted to make like a full suite specifically for your car or something, you could actually be able to calculate the arrival times and everything. And obviously when we do long distance, you can see that the charging stations actually include how long you have to stay to charge in the total trip time. Here we've just done sort of reachable range on one charge and then a trip on one charge, not accounting for stops and charging time. But it's a really good start to see, at least your departure time when you would arrive, what how much battery it's going to take you to get there to the point that you're estimating.
Correct. So as you can see, if you are only having half of your battery, you will not make it. You have to have full battery.
You have to stop in Mount Vernon.
That is fine. That is fine. But let's say if we go a longer route, let's go to Portland from Vancouver, you will definitely not make it.
Yeah? You definitely have to make probably at least looks like at least 3 or so stops to get to Portland.
Yes, and then you have to find a place to charge, right?
Yeah. And that's where things like the charging stations and the long distance routing API for EVs, the EV service API comes in, I think. For because right now we don't have the search for the charging stations added when we're making the calls and things like that.
So the error I got here is because I'm calling now. Let's see if you cannot make it. How about finding what stations, charging station do I have on my road? So it's, I don't remember if we already did this example before to make a search from the route, like search along the route. You can find POIs or objects that are along a specific route. And we're going to use again that call for getting all the charging stations that are along this route, for example. Olivia?
Oh yeah, sorry. I think there was a little bit of a lag. So are we going to add in waypoints or cut out for a little bit?
No, we're going to trying to find out the charging stations that are on the road, on this route.
So like charging stations along the route without interrupting the trip, basically.
Correct.
Because no
And
one
that's what
wants to drive 40 miles extra to get to the charging station.
Correct. So let's see. I have this. We already have the GeoJSON file, but I also have the result. So I want to show you something very interesting, cool here. We have this in the SDK for web. We have this API called AlongRouteSearch, and that allows us to search for objects, POIs, places that are along the route. And we just have to send the maximum amount that we can get is a 20, and from the route you select, I'm going to zoom in here a little bit. From the route you select how much detour time can you go all out of the route in order to find a specific POI. Yeah?
Yeah.
And then what are we looking for? Not gas station per se, we're looking for electrical vehicle stations. And if you, yeah. And the route itself is the waypoints of the route. Now, we can also add the category that we want to set. And I think I have the category for electric charging stations somewhere. I think it's 73 something, one of the 73. But we can try to, with this data, with this information we can hear and take a look at how it works. So I'm gonna copy this because this is, I think, so I haven't used this.
It sounds like we could also manually set the waypoints where we want to stop. And would we search within those waypoints, or are we just trying to find where's the charging station along the route purely?
No. Okay. This with this API call, we are only searching POIs or places that are close to the route that we're going to.
So just going to find the closest. Yeah.
The closest to the route.
Least extra driving time. Yeah.
Correct. How close? In this case, the maximum detour time would be 120 seconds. Yeah. I think it's a little bit too short, especially because there are.
You have 120 seconds to get to this charge point.
Yeah, that's. But okay, I'm gonna put some more. Probably we will not find, so we can experiment. Okay. So let me just copy this code because I haven't used that one in a while. Let's see. So it's called search charging stations. So search charging stations. And then I think we're passing something. Let's say data.
Passing in,
We're passing a result. Oh, the result from the calculate the route, from the route itself. We're passing the result of the route. All right. Okay. So I just copy the code. It's called TT service along the route, and then parameters, and then key is the API key.
And it's the same key that we've been using for the stream.
For the stream since forever. We have to find the limit. How many we have to maximum? I think it's maximum is 20 for now. And max detour time. Max detour
Not 120
Time.
seconds.
No. Let's see. Let's put at
Because it's
least
in seconds.
3,000. Yes, in seconds. 3,000 seconds
Yeah.
at 5 minutes or something. Yeah.
Yeah, we'll see if we find something. I don't know. I mean, for
Yeah.
Seattle, Portland, I'm sure there's something.
I'm sure we can find something. Yes. And this is the query we're looking for: electric vehicle station. All right. And now we are going to pass the route.
And then we'll see if we find.
Okay, the route is an array of. The route is an array. I can see that an array of.
So we should be able to use the waypoints.
Yeah. Well, no, not the waypoints. The route itself. We have to pass the route
itself. Oh, we'll pass the route itself.
Which, to be honest, I have to double check.
Let's see.
I have to double check. I don't know exactly what I'm getting. So in case I just display the data.
Yeah.
I want to see what am I getting. So again, beautiful Vancouver. We're going.
It's also very pretty drives that we're illustrating, I think, on the stream, because we're planning routes from Vancouver to Seattle and Seattle, Portland, all of which are great. Just as as an aside.
Have you been to Whistler? That's nice, beautiful over there. Just beautiful skin here. Okay,
I've only gone as far as Seattle.
Oh, you have to cross the border.
I know. Yeah.
Kamloops. Let's go to Kamloops.
That's what we on Reddit. I think we addressed a question about Kamloops.
Correct. We have a reader from Kamloops, indeed. Okay, we have errors, of course, but we have here the route, and I'm gonna close this. Not only this, so the routes is actually it's an array, and I take the first one, and since
we give us the route.
Yeah, the route, and then we only have one leg point. Probably it's only take the first leg, and the first leg has points. Here are the points, which is exactly what I want. Points. So it's routes and array, then legs, then points. So let's see. What is the route? We're going to pass from the data. We got the routes, which is an array. Let's get the first one. Then we get the legs, which is we want to connect with the first one, per legs,
and then we layers.
Yeah, and then the route points. Okay, I'm going to not draw this, but this call, I'm assuming it will give me a.
So let's see if it gives us a
function.
Charging station.
Correct. And we can draw it. We can see the results. What do we get? Okay, let's take a look again. So we're going from Kamloops. There it is, Kamloops.
You can find Kamloops, which is also a great name. I still think that's one of my favorite names for a place, personally. But
yeah, really?
It's very
good.
Fun.
Oh, there it is. Okay, I get something.
With the consumption, are we getting a
bunch of POIs?
So we're finding POIs. So that's good. So we found some charge points.
It's a charging park.
Nice.
It has an array with 2 connectors in different places. So we get a lot of
info back too.
Yes. Look at this. Also check the charging availability ID. This will be needed if you want to know if this you want to know the availability, which one is used, if it's available, yes or no. You use this ID for this value, but we're gonna do that in another episode or a Devisode. And we have the POI, and we have it's a Tesla. It's a Tesla station.
Oh, so it's a Tesla. Oh, so Tesla. Oh, so we get a lot of info back. So if you wanted to create sort of like your own directory, you would get the name, you'd get how many connectors they have available, the website, the phone number, which is actually really fun.
We have the position, which is lat and long. And I think we have to, from each one, we're gonna get from the results, we're gonna get the position, and we're gonna create a marker, and we're gonna see how it looks like. just because
Cool.
quickly. Yeah.
Just we'll put a quick marker so we can see our charging point on the map.
Where are they? Take a look.
Yeah, we're all the charge points.
Let's take a look. So first, let's take a look if, first if the results, okay, well, let me check the work here. These results array have 20, so we have to check if we have results. Otherwise, it makes no sense. Or, okay, wait. Well, even if we don't have results, it would be fine if we just go results, result, and it's an array, right?
Mm-hmm.
Yes, an array. So for each element of the array, let's say it's a POI, it's passing a POI for each element of the array. What do we do? For each element of the array is called POI as well. Oh, just not to get that confusing, or call it element.
Okay, yeah.
Just not that confusing. What we're going to do is to create a marker. So marker.
That'd be fun because I'm interested to see visually how many stops we have as options between Kamloops, which is still fun to say, and Vancouver.
Yeah. TT marker. So wait. But let me see. Let's set the long on lat. For this is the element. The element is called element position. Double check. So this is the element, the POI position. It's at the same level of everyone.
Oh, okay.
So that means it's at the same level. So it's position, and that's the position. Okay, of
so
the
it's just position.
marker. Yeah, and then just add it to the map.
Yeah.
Just
so pretty
quick and dirty.
Marker.
Quick and dirty for now. How about that? It's a quick and dirty. We're not added in. We're not. Just I want to see it. I want to see what it is right now. Okay.
Yeah, just a very quick marker. Okay, let's see.
Let's see how it looks like. All right. Okay, let's start. So we are in again Kamloops. Again, it's too far away. Oh, here it is, Kamloops. Hello. Let's say I'm gonna open the map a little bit.
Oh, we have the reachable range.
Yeah, by mistake I click. So obviously, let's do the now Vancouver in BC, because I know there's a Vancouver in Washington.
Also noticing you can drive pretty far from Kamloops.
Yeah, actually. Oh, I just click here by mistake. So let's see. And voila.
Oh yeah, so we see the markers.
We have markers, and
those are all the charging points.
Charging
for every result for a charging point, basically, that comes up from the search. So very cool. So we have a route. We have reachable range from Kamloops.
Well, I'm going to click it here. I'm going to click here. From Kamloops, we can reach up to here, right? Okay. So that means we
are going of the drive. Looks like.
Yeah, remember we're having half of the battery, so we can change it to full battery to see how it looks like as well. So if you are right here and you charge here, then from here you will be able to reach all the way here. But again, this is half the battery. You can, if you're full, probably you will reach more. You might make it in 2 charges. Yeah. So the whole reason I wanted to show you is because even that we have a reachable range and we have creating a route for electric vehicles, and even that we also have fetched the along the route what are the charging stations, you see how it gets complicated creating a route for electric vehicles in that sense. Even that using the API is quite easy, but all this combination make it a little bit more complex.
Just keep increasing the complexity, because even here we don't calculate the full extent, which is seeing how long you'll have to charge for, how it'll impact the route, and all these different things, which is part of using more of the APIs. So here we're kind of just on a basic routing, basic reachable range, and we actually did get to the charge points where you can see at least where they are, and you can see the POIs along the route, so you don't have to drive very far away or do a separate search.
Correct. So that leads us to this new API. Was not new anymore, but it's very interesting API that we have created, like we implemented, I think it was last year already. It's a long distance EV routing, which does everything for you, as you can send the same parameters or similar parameters to calculate a route for electric vehicles. And what it does is mostly what we want. It can calculate a long distance route, and it will tell you where to stop because it will find the charger for you. And then it will tell you how long will actually will be able to stop and how much charge. You can tell it, okay, I want to stop here, and I want to spend no more than so much time in this station, and then you can resume your driving to get to your destination with one single API call.
Yeah,
and that
it's
is
basically
I think,
all customizable.
Correct, and that's what we want to do in our next episode.
Yeah, but that's basically so that's basically the part 2 of our EV where we get a little bit more complicated, a little bit more specific. But that's a wrap on our EV routing with the Audi e-tron, which was a lot of fun.
Yeah, so it's very nice. Like, for example, you could say, okay, I can stop here in this area, but once you stop there and you are charging, if you are on a car, you have to stop at least 1 hour, 2 hours. Depends. If you have a fast charger, then it's
Yeah, and
different.
something
But
we didn't include in the part 1.
including it's nice if you have an API call already that calculates that for you.
Yeah.
For example, and you can even find out what is around. Maybe you want to go and have a bite in a restaurant around. We can find also something happening around the area where you are charging, for example. Yeah. Most importantly, every car. Let me see. If you take a look at the Audi, in this case the e-tron, you see that this is used in a Type 2 EC60 group. Yeah, and sometimes we can. I believe that we can also have there's an adapter for Teslas as well, or you can different adapters, and
Yeah, you
with
can
the
find
API,
the adapters in the results.
you can also find in this.
Yeah.
You say, I have in this car, I'm having this adapter, and please find me charging station that are compatible with this adapter, please.
Yeah.
And it will find it for you, and it will calculate the route for you in this case. So it would be also interesting episode, like the second part of this.
Let us always let us know and ping us on Twitter if you want to see more EV and what questions you have about it too. And I think since we're basically wrapping up, also a last shout out and thanks that we finally reached 200 followers, which is great to see. This is again a small replacement for our meetups. So we've been doing, this is only our 9th Devisode, which I feel like it still feels like a long time, but we've only done 9 of these. And we actually have a little community of people that are watching, our videos, and so a huge thanks. We like streaming and showing you how to use the APIs, so it's fun.
Cool. Wow, I'm gonna play a little bit more. Yes. I like it. Nice journey here. Ah, nice. Excellent. Okay, so I think we are closing up. So thank you very much, Olivia. I'll see you in the next one.
Thanks. We'll see everybody
see you
next
guys,
time. Happy mapping.
Thank you. Happy mapping. Thank you for watching.